Thanks, Lauren. Welcome, everybody. How's everyone doing?
Good.
Okay, so I saw a lot of boards going across, and it seems like you've had your fair share of technical input, and what I wanted to do was actually track the rise of artificial intelligence. So I myself have been part of 2 AI companies, most recently one that is headquartered out of Singapore. And what we do is image-to-image recognition and image-to-text recognition. So we do a combination of deep learning and computer vision. And we work with a whole host of retail clients right now. We've grown. We're sort of in Series B mode. We're looking for people too. So if you were looking for jobs and stuff too, we're more than happy to have people. So that was, prior to this, I was actually at a drone company where we actually used to build B2B enterprise drones. It was incubated out of NASA, and basically we used to work actively with the DoD, including going all the way to Nepal to work with the Nepali government to actually save lives with our 3D renditions and our heavy payload drones. So that was an exciting project. We had a phenomenal team working on that from different arms of the government too, including several members of the Silicon Valley arm, people that you probably know in the AI field. So that was most recently in AI. Prior to that, I was a co-founder at an MIT Media Lab company where we used to build smart home routers and smart home technology. It was a very exciting project. We were able to partner with several interesting companies, including Amazon and Nest, and we eventually sold to a Chinese conglomerate back in China. So been associated with the field. I also have done a very interesting program out of NASA called Singularity U. So I did their summer program where I actually was able to use machine learning algorithms on Landsat images to do predictive environmental threat detection. So a lot of that initially was to actually predict environmental threats like algae blooms, oil spills. We use a lot of Google Earth's API, and then we used to work with the EPA. Eventually we discovered that there's no money in that, so we pivoted to drones. But it was a very interesting project nonetheless. I highly encourage people to take a look at the work that we had developed initially. And I'm happy to answer questions regarding anything that we're working on now or current or in the past, whatever we did. So with that, I thought that I would want to track something that discusses the history of AI. So typically when we think of AI, we think of today's current day applications, right? Like we're thinking of NLP, we're thinking of like chatbots, we're thinking of drones. It's like it's the thing that Y Combinator and Singularity U and many institutions like that have popularized, and they've trickled down into the Middle East, into China, into London too. I was advising a drone company in London on how to do crop disease detection using drones. So this has become a worldwide phenomenon, but it's always good to understand the roots. Many of the people who have studied AI academically probably are aware of the key figures or the key names that I'm going to be discussing, but I'd like to get into a conversation about where this all started. So it all started with a simple mechanical calculator where we did arithmetic calculations. So this was born in 1642. This is the early precursor to any sort of AI. You could argue that the syllogism, which is basically the thing that Aristotle came up with in 384 BC, was the early version of AI where he actually proved the concept of deductive reasoning. So for example, deductive reasoning is Socrates is a man, all men are dorks, Socrates is a dork. And that is deductive reasoning, and that has actually been the meta layer for Boolean math and Boolean algebra, which has actually, of course, come into our algorithms that we've popularized today. So started with the mechanical calculator, goes into Charles Babbage, who was the father of the first computer. So this mechanical contraption over here was actually the reason why Charles Babbage is known in the field as the pioneer for early version computing. It seems like there is not an interactive display, but this is very much the way we were able to do some of the early base computations all the way back to 1822. So AI is definitely not something that is a 21st century topic. Peter Norvig, if you have a conversation with him, will tell you that this has been a challenge since the 1970s and 80s, and we haven't been able to crack it mainly because of the lack of data or the lack of GPUs, and we're actually at that inflection point where we're actually able to make those systematic changes, which is why this topic becomes exponentially interesting. So we go into the Turing machine. Everyone knows who Alan Turing is. Everyone knows who's probably the father of AI. One of the things that I got excited about back in the day, this is just a little story, is that about 5 years ago, I bought the rights to Turing Fund. So because I wanted to start the first AI angel fund, but I got more involved on the operational side. In fact, if anybody's launching their own venture, I encourage you to look at neuron.vc. So it's the first AI dedicated fund. It's available on AngelList, and you should actually look at their syndicate and see which companies are they funding, because they're funding some very interesting technology.
What was that again?
Neuron.vc. So ex-Googlers / industry veterans. Going back to 1948, cybernetics. So something where, of course, when you think of the Terminator, you think of Skynet, of course, it comes before that. There was the topic of cybernetics that was discussed. And when you contrast that with AI, there is a stark contrast in 4 different fields. One is representation, memory, reality, and epistemology, which basically says that cognitive systems are inside and outside versus being autonomous. You have organisms mapping external objects to internal state versus through the environment. You have the nervous system that stores information versus adaptive relationships. So cybernetics was eventually brought into the AI field as well, because a lot of this cannot exist independently. These challenges, at the heart of what you believe is the definition of AI, they coexist together. So, has everyone read the general AI book by Norvig, and where they think about like the machines? What is your definition of AI? What does AI mean to you? Does it mean think rationally? Does it mean act rationally? Does it mean think humanly? Or does it mean act humanly? And those topics really change the way you design AI. So Superintelligence, which is a book that Nick Bostrom wrote about, he is currently a professor at Oxford. It is a phenomenal book which talks about what you can take all the tech in the world and you can actually create a rational system, but a super rational system does not mean that it's necessarily intelligent. It's just a super rational system. So the way we actually evolve the definition of AI is going to actually tailor the engineering and the future leap in the field itself.
Are your slides somewhere?
Yeah, I'll send them across. So 1950 is the golden year. The 1950 is when we actually 3 breakthroughs happen. The Turing test is passed. We have Claude Shannon, who actually uses the search algorithm in chess. And then Isaac Asimov develops the 3 laws of robotics. The 3 laws of robotics, probably everyone has read or recalls, are a robot may injure a human being through an action, or sorry, may not. That's very important. Take that
You
back.
were there.
That would just be completely contrary. Through
Error we have to watch out for.
Yeah, exactly. Thank you. Through an action, allow a human being to come to harm. Number 2 is a robot must obey orders given to it by human beings, except where such orders would conflict with the first law. A robot, the third one being, a robot must protect its own existence as long as such protection does not conflict with the first or second law. Unlike Newton's laws, these ones are codependent on each other. The second one kicks in when the first one is true. The third one kicks in when the second one is true. It's almost like the precursor to the decision tree, basically. Going back to 1956, after 1950, this is an infamous conference. This is where the term AI was coined, where Marvin Minsky, John McCarthy, Claude Shannon, who was the father of informational decision theory, they all met and they said, what is artificial intelligence? We have to create a field, we have to give it a name. And these are all the pioneers. And as you can see, it's also gender neutral. So going back to the Silicon Valley tech argument that we need more female engineers, which is an important topic to be had, there were very interesting women back then that were making phenomenal leaps in the AI field as well. Perceptrons. I'm not going to go into the technical aspects of what a perceptron is, except that it was developed by Frank Rosenblatt back in 1958. I see on the boards back there that there's been enough discussion about perceptrons over the course of the weekend. So I'm going to move forward to the first NLP development, which is back in 1968 to 1970. This is basically at the University of Utah, and they were basically using NLP to get the computer to understand how to move objects. So the script on the right is an actual script of human beings interacting with the bot. So the person says, pick up a big red block. The computer says, okay. Person says, grasp the pyramid. Computer says, I don't understand which pyramid you mean. And then, of course, this is just a small snippet of the entire script. But this is the early version of NLP, going back to actually the 60s. Backpropagation, again, it's one of the most popular algorithms that is out there. Pedro Domingo will also, if you've read his work too, has highlighted the backpropagation, nearest neighbor, and of course are some of the biggest algorithms in the AI field. And of course, you guys have covered it in the back as well. So moving forward to the first autonomous car. This is kind of cool. So this was actually developed in 62 and 63, but then the operation for further development of the Stanford cart was stalled when actually Professor Kennedy focused a lot of the funding, President, Jesus. President Kennedy focused most of the funding on actually the moon missions. So it took a temporary stall, then actually they kickstarted back again, I want to say around 65, when Professor John McCarthy got involved. And then since then, it became part of the Sale Institute, and then it was eventually tested in 1979. So this relic of an autonomous car is available on Stanford's campus. I encourage you to check it out. It is a very interesting work of engineering because, as you can see, it is one of the first places where Hans Moravich discusses the Moravich's paradox, which is that most of our computing power goes towards low sensory motor skill work, and we don't need as much computational power for our high-level reasoning. This was, the initial discovery was made post-Stanford Park. Moving forward to Alvin. Everyone familiar or heard of Alvin? It was one of the autonomous land vehicles and neural network. It was a phenomenal breakthrough. In fact, I'm going to play the video in a minute. But this is also incorporated in the curriculum at Udacity. So Sebastian has the driving engineer or autonomous car engineer nano degree, where if people wanted to become autonomous car engineers, you can actually be part of this 9-month program. It's a SaaS model, you just subscribe to it. And they teach you the fundamental principles of Alvin as well. So I'm going to click on the video. Let's see if the volume is there. I'm going to run it for about a minute. It's about a 3-minute video. But this is actually using the early day LiDAR systems for spatial recognition. And they use this at Carnegie Mellon. And as you can see, this is completely autonomous. There's nobody inside. They're trying this out on campus. Oh, sorry. The other one, I think they're... Wow. Okay, at some point there, it's going to kick in, but... Okay. Anyway, check out the YouTube video. It's a little more interesting because at some point he lets go and then you see the autonomous car in action. Moving forward to... How do I... Moving forward to 1991. So this is the development of the DARPA system, which is a dynamic analysis and replanning tool. So especially during the Gulf War, they started using the first autonomous drones. Of course, when we associate drones and drone-based warfare, you have this picture of dystopia. But initially, it was designed for monitoring and for borderline security work. I had the privilege of working with some very interesting drone mission commanders back here in the United States. So those were the fundamental people at our company, Halo Drop, that were helping us develop our heavy payload drones for government security detail that we did at the home base over here with Homeland Security and back at there in Nepal. So the big thing over here is that because this was successful, DARPA actually funneled a lot of money over here for the more money now since compared to the past 30 years in its AI research. So it was a big breakthrough point. 1993, another autonomous robot. The difference here being that this is actually the first precursor to Roomba, because this was actually a robot that could actually do spatial navigation. Of course, it just moves around and understanding the space that is around it, and of course, light-based LiDAR systems. It is actually able to evolve its algorithms, and it's able to operate in the room seamlessly. A very positive test. Of course, now, when we think about things like Roomba, and we think about it when it's put on the market, it's seamless. Like you're thinking, wow, this technology, of course, has existed for a while, but the technical development to get to this point was phenomenal. Fast forward to 1997. Everyone know this moment? So, Deep Blue, the computer, beats the Grandmaster himself, Garry Kasparov. That face is not a happy face when you know that an algorithm can beat 40 years of working nonstop on the best chess strategic moves. But it did, and it's been an incredible breakthrough. The Grandmaster himself conceded that this technology was so powerful that AI would eventually when we think of it, we think about like the limited number of spots in a chessboard, but it's actually billions of combinations that determine why an AI is particularly good at playing chess. It's the number of combinations versus the number of spaces that you see on the board. So this is why Garry Kasparov conceded, wow, that technology will take over things like gamification, chess, and it will be used for more high-level purposes in the field of strategy. So this is a curve that I see everyone discussing today. This is proposed by Gordon Moore. It is the point where the singularity is kicking in. The singularity is near. Ray Kurzweil is also one of the people that keeps discussing it in his books over and over again. It's basically that the price of technology has dropped, the number of GPUs has doubled, and this has led to the point where technology is going to become a more democratized process. There are more players getting involved in the topic of AI, as clear in this room, than ever before. And that's because the process for developing the tech has become a lot easier. Because it started with hardware, but we're seeing this democratization trickle into software and to other tools. You can see that the company that I'm with, ViSenze, which is HQ'd in Singapore, to have a conversation about AI was probably it was interesting, but it wasn't considered. Now it's a topic that we can have because everyone has the tools to develop these AI in any part of the world. So it's an important curve, not to confuse this with the Gartner cycle too. The Gartner cycle is, of course, something that we should all bear in mind when we're thinking that the barrier to entry is actually not the technology itself, but it's technological adoption. So you have to make sure that even if you develop the technology, it's more important not to commoditize it. It's a race to get the market. How do you get people to come onto your platform, to use your technology, versus worrying about whether you're going to be able to build it itself. So when you are thinking about building AI, think about it holistically, about like, how am I going to get the customer base as well? Because the use cases are great, but the use cases are incomplete until you have actually good testing, market validation. I've had to learn that the hard way, trust me. So fast forward to today, 2005 was the first robot, Asimo. 2009 was Tokyo. These are all coming out of Japan. So contrary to things that are being built outside of like here home base, they're happening all over the world. We're seeing new bots. In fact, the first autonomous factory was in Korea, in Seoul. So you're seeing like car companies like Kia and Hyundai adopt these even before local car companies over here. So it's something to be aware of, that when you are having the conversation of AI, think about the global spectrum. Just don't localize it to what we see in the valley itself. Drone survival guide. I like showing this slide because we had to build drones. We built drones from quadcopters to fixed-wing drones, trying to understand payloads and the sheer number of drones. This is mostly defense-based engineering, or like things that Boeing and Lockheed would develop. But this, if you go to the next one, these types of drones are being built by everyday college enthusiasts, drone hobbyists. They're also being built, so initially Chris Anderson, who was the editor of Wired, he created the drone company forum, not Drone Deploy, but look at it. It was basically, his co-founder was somebody that started posting articles about how to build new kinds of drones using nanomaterials and bioplastics. And that evolved into what we know today as 3D robotics. So you can have like a young 21-year-old that just came out of nowhere with Chris Anderson, and they built these drones. And now you can use them from every single field. If it's in agriculture, you can do it for like crop yield optimization. You can use it for disease detection. You can use it for yield optimization, and people are using these actively. That's the low-hanging fruit, because it's easier to use drones outside of city limits. So their FAA, which is the Federal Aviation Authority, imposed a limitation of that you cannot fly drones within 30 miles of any urban city center. So because of the line of sight rules and that constitution that FAA has developed is evolving, you see people using it particularly in agriculture, then in infrastructure, analytics. So how do I take photos of oil pipelines or buildings? How do I optimize engineering of buildings? So that's a very interesting use case. And depending on the altitude, the battery runtime, you actually decide to go with a quad versus an octocopter. the design is based on how the frequency, the battery packs that you use. We've also seen new developments in the drone industry, which is actually using solar fuel cells on drones. That has to be optimized. It's still going through the Moore's Law curve, but I'm sure we're going to see more interesting developments in this space. Chatbots. Chatbots are always interesting. This is going across industries. So of course, TechCrunch built its chatbot on top of ChatFuel. So there are a lot of people that are doing now AI as a service. In fact, they're doing chatbots as a service. There's a company called Octane.ai where Ben Parr and Matt Schlitt, they basically are, Ben used to be one of the editors of Mashable, basically, and now this is his newer venture. They created chatbots as a service you can build on top of their platform. And now you can do this in health, so you see a lot of big health bots. Look at a company called Doc.ai, which is basically based out of Palo Alto right now. So Walter, who is the CEO of Scanadu, actually this is his newest venture. There's another interesting company called Pana, which does chatbots in the travel and hospitality industry. They do everything from automatic check-ins to basically getting you set up. All you have to do is say yes. Your credit card is already preloaded into the system, and your ticket is bought, and you're on your way. Chatbot full end-to-end. So this, and then of course you have it, so it depends on whether you're doing a platform strategy versus a solution strategy. Platform strategy is where the chatbot is baked into the cell phone, so it's like Siri, versus like having a solutions-based thing where it's very sector, vertical specific. Of course, AlphaGo. This was the big development. I'm sure that you guys know about it, courtesy of Google DeepMind. IBM Watson, another interesting thing. We obviously saw Watson beating Mr. Jennings, breaking the biggest streak in Double Jeopardy history, a robot that can trump everything. In fact, IBM Watson's API is now available for development. So you can actually build on top of them. They let you, if you have a use case and you're not sure if you have the technical chops to build it, look at their platform. They can support you end to end as well. ViSenze, this is one of the companies that I'm associated with now. We do computer vision and deep learning. This is basically contextual product optimization. So people can discover products easier. People can discover products that are relevant to them based on pure vector data. So this is not based on any social sentiment data or analytics. It is if you choose to combine it with price intelligence and consumer behavioral data, that's interesting. But this is purely based on visual patterns. There are a few companies in this field like Clarify is doing some interesting work. CloudSight's doing some interesting work. Sentient.ai, actually, in recent news, they've chose to focus a lot in this field as well. So there's a lot of interesting developments coming in this realm as well. And it takes on the problem of customer engagement, product discovery, and the third one being a catalog optimization. Prediction markets. Some may argue that this is fail. Some may argue this is a succeed. I had a big debate yesterday about whether you actually believe prediction markets work. It's not a be-all, end-all solution. I do not recommend anybody trade based on pure prediction markets. I would always say that predictive analytics are better than prediction markets. Predictive analytics are things that you use to actually understand patterns, but it is not the way that you want somebody to broker your trade. And because you could argue that there are several factors that lead into any single decision. Political factors, there's socioeconomic factors, there's social media factors, whether you were actually reading all the details on it. But an interesting space nonetheless. An interesting company doing some good AI work in the fintech field is a company called Kensho. They are funded by Goldman Sachs and Google Ventures and a couple other companies. TensorFlow was covered in active detail. This was a huge landmark where we're now open sourcing all our AI too. In fact, OpenAI, which is going to be covered, I'm sure, in the next discussion, which is the ethics of AI, is also a field that is an interesting institute. I encourage you to go on it and see what are the ethical arguments that people are working on. In fact, from ethical arguments, which are basically massive representations of problems, they actually can be the perfect place to look for use cases to actually develop your new AI, because those are the things that are being vetted very actively. We want to prevent any future threats coming up in the next decade or so. So OpenAI may be a very good resource for you to look for your next AI startup idea if you had one. And finally, here are some frameworks, tools, libraries. Yeah, so that was pretty much it. I hope that was useful. And if anybody has any questions, I'm sure Lauren can get my information. But thanks for giving me the chance to be up here, and it was great. So.